Good morning, all of you. I'm your physics educator, Ram Chaudhary, and I am currently working with India's most reputed IT company, Resonance. And today we are gonna discuss about circular motion in vertical plane, which is the concept of a classic mechanics. You can say concept or it's basically application of mechanics. Okay, let's start. Let's assume we have a string which is fixed from point O, one end fixed is from point O and another point, a mass small bob is tied at another end, and this configuration is allowed to move along the vertical plane. So let's draw. Okay, let's assume up. Let's say this string of having length L0 and this end is fixed from O, and this mass M and this mass and the string is free to revolve around the vertical plane. So, so let's try to understand the mechanism of this vertical circular motion. We can clearly see that there are three forces. First of all, there is a force that's known as hinge force. Second one, that's tension in string, tension force in string. And third one is the field force, that's gravitational. Gravitational. Gravitational field force. Okay. Now let's see work done by hinge force, work done by tension force, and work done by gravitational force. We can simply evaluate the work done by these work done by due to these three forces. First of all, hinge force. Let's work done by hinge force is a simply force is a force acting hinge force and displacement dx. Point of application of hinge force is O, and during the vertical circular motion this point doesn't displace, and the point of application of force doesn't displace. That means work done by hinge force is zero because of point of application doesn't displaced during the circular motion. During the circular motion. So first of all, work done by hinge force is zero. Then second one, work done by tension. Tension is responsible for circular motion, and tension is always perpendicular with the movement of this mass. So displacement and tension, force and tension, angle between them is 90 always. So work done by tension force is equals to force, tension force, and dot dx, and simply f dx, angle between them is always remain 90. So work done by tension also 0. Okay. Now work done by gravitational force. Work done by gravitational force. We know that it's a conservative force. So work done by a conservative force, work done by conservative force is the negative times of change in potential energy is equals to minus of change in potential energy. So work done by conservative force is equal to minus of potential energy final minus potential energy initial, and now potential energy initial minus potential energy final is the work done by conservative force. So we have work done by these three forces. First of all is a hinge force, then tension force, then third one is a gravitational force. Now we can combine this by using work energy theorem. Work energy theorem mention these all the forces work energy theorem, work done by conservative forces, work done by non-conservative forces, work done by external agent, and work done by pseudo force is equals to change in kinetic energy. So there are conservative, that means gravitational force. Second one is tension. Third one is hinge force is equals to kinetic energy final minus kinetic energy initial. Okay. Now work done by tension force 0. Work done by hinge force 0, as you can see previous. So work done by gravitation is negative of change in potential energy is equals to kinetic energy final minus kinetic energy initial. Negative of potential energy final minus potential energy initial is equals to kinetic energy final minus kinetic energy initial. So kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. So we can simply say that mechanical energy is conserved for this configuration because of there are no non-conservative forces. Okay, mechanical energy is conserved due to absence of non-conservative type of forces. So we can simply say that loss in potential energy is simply gain in kinetic energy and vice versa. Loss in kinetic energy is simply gain in potential energy. Okay. Now let assume we have a circle and this point O, this is string, and we deliver a initial velocity along the horizontal u, and this is hinged force, this L naught, and t is equals to 0, t is equals to t time particle or string makes an angle, angular displacement with the vertical, so theta. Now consider to frame of reference. Let assume आपके पास में this frame of reference, so it's a initial condition and this is final condition. So kinetic energy, potential energy is potential energy initial plus kinetic energy initial potential energy final plus kinetic energy final. Potential energy initial is 0 because of particle at the reference point, so potential 0, plus kinetic energy is initial half m u square potential energy, let assume velocity v at that point, and particle is displaced by this L and this L naught cos theta, So mgl naught 1 minus cos theta plus half mv square. Okay. Then m you can cancel out simply m, and u square by 2, u square by 2 is equals to gl naught 1 minus cos theta plus v square by 2, and we will get u v square is equals to u square minus 2gl naught 1 minus cos theta. Question number 1. Okay. Then try to figure out the tension force at that point. Let's assume T, and gravity is acting downward, mg. Gravity is acting downward, mg, and this angle is theta, so this component is also theta. Then this mg cos theta. So particle is performing circular motion, that means there is a required force, centripetal, and that required force is T minus mg cos theta is equals to Fc. Fc is mv square by L naught. T is equals to mg cos theta plus mv square by L naught. T is equals to mg cos theta m by L naught, and v square. We can substitute this value, u square minus 2gl naught 1 minus cos theta, 1 minus cos theta. So you will get mg cos theta plus mu square by L naught minus 2mg and minus plus 2mg cos theta. So tension, you will get tension is equals to mu square by L naught plus 3mg cos theta minus 2mg is the tension in form of initial delivered velocity. We can also find out, that means this tension at point B, so TB, so this TB. Let's assume this point A, so we can also find out tension at point A. mg is simply acting, and TA minus mg is equals to Fc. Fc is equals to mu square by L naught. TA is equals to mg plus mu square by L naught. Okay guys, so by this term we can simply find out tension at any position of particle with the vertical. Okay, and this is the velocity by using the energy conservation because of absence of non-conservative type of forces. Okay, hope you understand. Thank you.